The dosage for a certain drug calls for 15 milligrams per kilogram per day and is divided into 2 doses, like every 12 hours. So if a person weighs 160 pounds, how much of a drug should you get in each dose? Now think about it. You're given the weight in pounds, but the drug is given per kilograms. So the first thing we need to do is take those pounds and change them to kilograms. So that right there takes me out of pounds and into kilograms, because once I have my weight in kilograms, then I can use 15 milligrams per kilogram. So this setup right here tells me how many milligrams this person needs to get total. So this 3 steps is a total, but it says it's divided into 2 doses. So we want to take this final answer and divide it into 2 doses. And when you do that, you should get 544.32 milligrams per dose. That's a decimal point. Similar problem. Now we're having a drug that's 25 milligrams per kilogram per day into 3 doses. So this person weighs 250 pounds. So we start with the weight, we change the weight into kilograms. Because again, the dosage is per kilogram. So once I'm in kilograms, then the dose can be applied. 25 milligrams per kilogram. Okay, so that gives me, again, this is the total milligrams given, and this is done in 3 doses. So I divide the total by 3, and that gives me 945 milligrams per dose. If a drug has a concentration of 375 milligrams per 10 milliliters, right, so that's basically 375 over 10 milligrams over milliliters, how many milliliters are needed to give 1 gram of the drug? We're setting up a proportion. Now hopefully you say, ooh, problem. I have milligrams and grams in the top. Those are not consistent. So you just need to decide what you're going to do. You need them to be the same units. Which one are you going to change? I'm opting to say, you know what? I'm going to change grams to milligrams. So I know that grams are here, then deci, then centa, then milli. So I need to go right 3 places. So this is really 375 over 10 equals 1,000 over x. Thinking about milligrams over milliliters. So now I can solve this proportion, cross multiply and divide, and I end up with 26.67 milliliters. Just make sure you have your label correct. How many milliliters are needed to give 1.5 grams of a drug that has a concentration of 400 milligrams per 10 milliliters? Same basic problem. We have milligrams here and grams here. Now let's go the other way. If I have milli, centa, deci, and then here's the grams, if I want to change my milligrams, I'm going to go left 3 places. So this is the same as 0.4 grams. So now I can set up my proportion. I'm going to go milliliters on top, grams on the bottom. So how many milliliters are needed to give 1.5 grams if we know there are 10 milliliters for 0.4 grams? Doesn't matter which one you put on top, you just have to be consistent, right? Right now I have grams on the bottom, milliliters on the top. I cross multiply, I divide, and I end up with 37.5 milliliters. A doctor orders an IV of 1.25 liters every 2 hours. The settings for the IV drip are in milliliters per 1 hour. So what setting should you use? Okay, so look at what you're starting with. First, I need to change liters to milliliters. Well, that just means I have to go right 3 because we have liters, deci, centa, milli. So I'm going to go right 3. So this is the same as 1,250 milliliters every 2 hours. Okay, we're getting closer, but this is per 1 hour. So I simply divide, right? The fraction bar is the same as a division bar. So if I divide, I end up with 625 milliliters per every 1 hour. And there is your settings for your IV drip. Last problem. The doctor orders 1.5 milligrams per kilogram of a drug for a child weighing 88 pounds. The drug is available as 125 milligrams for 2 milliliters. How many milliliters must you administer? First things first, you need to figure out how many milligrams this person needs. So we start back like that very first problem. Pounds to kilograms. So that makes then I can use my dosage. 1.5 milligrams per kilogram. Okay, so that means I now have 59.8752 milligrams. That's how many total milligrams this kid needs. Well, we know that we have to use 125 milligrams per 2 milliliters as the drug availability. Okay, so that's kind of how it works. So we're trying to figure out how many milliliters will we administer if the kid only needs 59.8752 milligrams. So if we set it up this way, right, the right ratio is the way the drug is available, the left is what we need. So we cross multiply. This child just needs 0.958 milliliters of this drug.